Here we have another solid of revolution problem. The curves we're given are x equals 2y squared and x equals y squared plus 1. Notice both of these are of the form x equals, and since the other sides both involve y squared, these are going to be parabolas. They're going to be opening to the right. It is helpful to know where these two parabolas are going to intersect. Let's figure out the intersection before we graph them. We want to know where is 2y squared equal to y squared plus 1. We subtract y squared from both sides. We would get y is plus or minus 1. Okay, so these are going to intersect when y is plus or minus 1. So if we graph maybe positive ones here, negative ones here, we know that these two curves are going to intersect at those points. The first one here, the red one, the vertex is going to be at the origin. Okay, that does go to the point 0, 0, so that parabola is going to look something like this. Okay. The blue one, since it's y squared plus 1, that's going to be shifted 1 unit to the right. The vertex of that parabola is actually going to be at 1, 0. So it's going to, it's going to have its vertex right here, but it is going to intersect the red one at plus and minus 1. So it's going to be a parabola that's got a little bit different width to it. That's going to be what that parabola looks like. And so the region in between those two is right here. Okay. This is definitely a dy region, since it's got a, since the equations are given in the form x equals, and just from the geometry of the region, the blue one is clearly on the right side and the red one is clearly on the left side. So we're going to do this as a dy region. We want to take that dy region, we want to revolve it about the line y equals negative 2. So y equals negative 2 would be down here. Here's the line we are revolving around. I guess I could make it green. Okay, so we're taking this region, we are revolving it about this line. To do this, so we're doing a dy region around a horizontal line, so we are going to use the shell method here. We're going to take an arbitrary strip at some random y value between negative 1 and 1, and we're going to take that strip, revolve it about that line. We're going to get a shell which is kind of on its side. The shell is going to look something like this. Okay. Let's go ahead and write down the formula for volume using the shell method. The volume, in this case, it's going to be the integral from negative 1 to 1, 2 pi times the radius of the shell times the length of the shell dy. Okay, so it's going to be 2 pi RL. The radius of the shell is the distance from that strip to the axis of revolution, which we could measure that on the y-axis. That's going to be the vertical distance between our y and y equals negative 2. So it's going to be y minus negative 2. In other words, y plus 2. So let's see, we still got integral from negative 1 to 1, still got a 2 pi in there. But yeah, the radius of our shell is going to be y plus 2, which is just the simplified version of y minus negative 2. The length of the shell, the length of the shell is just the length of the strip, and that's just going to be the difference between the blue function and the red function. That's that horizontal distance. So the length is going to be right minus left. Y squared plus 1 minus 2y squared. Now we have, we have the integral set up. Now it's just a matter of doing, just simplifying, integrating, and plugging in our endpoints and subtracting. We can pull the 2 pi out. Inside the green set of parentheses here, y squared minus 2y squared, that would be a minus y squared. So this would be 1 minus y squared here. We've got to FOIL that out. If we did, we'd have minus y cubed minus 2y squared plus y plus 2. Okay. Now I will integrate each term. You get minus y to the 4th over 4 minus 2/3 y cubed plus y squared over 2 plus 2y, and that's going to be evaluated from -1 to 1. If I plug in y equals 1, I use my calculator and turn it into a fraction, I get 19 over 12. If I plug in y equals -1, again, use the calculator, turn it into a fraction, I would get -13 over 12. So really what I have is 19 plus 13, which is 32. So it's 2 pi times 32 over 12, which if I multiply that out, turn it into a fraction, I'm getting 16, and there's a pi in there still, so 16 pi over 3. That would be the volume of that solid of revolution.